Stationary points can be identified when the derivative of that function is equal to 0. The derivative function always gives us the slope or the gradient of a function. When it is 0, that implies that the slope is horizontal. These slopes can either be found at the maxima or the minima of a curve. So if I was to draw a tangent here, and at the minimum, this is our maximum and our minimum. Now you can see that they're called stationary because in a way you can stand on them. Think about yourself standing on top of these gradients or these slopes. We can also have a horizontal gradient on a curvature where it is horizontal, but it is not a maxima or a minima. For instance, if I was to draw a curve like this, you'll find that here I can also draw a horizontal gradient which will go through this particular curve, point of curvature. Same thing, I can just draw another one here in the opposite direction, and you'll notice that that also gives me another horizontal point on this curve. And these points are called stationary points of inflection. So we'll call them stationary points of inflection. And once again, we can have a little fella standing up over here as well to show you that this is a horizontal tangent. And these 2 points over here, which we'll call the turning points, and the other 2 we'll call the stationary points of inflection. Now, what have they got in common is the fact that you can find them both when the derivative of x is equal to 0. That means the tangent or the slope has to be 0 at those points. And the sign diagram at these points will be like this. Let's have a look at the maxima. The sign diagram where our little man is standing will be positive on the left-hand side and negative on the other side. The sign diagram of a minima, where our man is standing, is going to be negative on the left side, positive. What's going to happen with the stationary points is that our sign diagrams with our little man here is slightly different, because you see the slope is negative on one side and it is also negative on the other side, and the slope is positive on one side and positive on the other side. Now that's how you can identify whether they are stationary points of inflection or turning points. There's another turning point on a curve which has a point of inflection, but this time we are going to draw it like this. What if I have a point like a function as such, with obviously a maximum and a minimum here? You can see that between here there is a point at which the curvature, the shape of the curvature changes. And even though from here to here, you'll note that the slope is positive, there is a change. there is a change of curvature. So let me explain. From here to here, let's check what exactly is happening in here. If I get a ruler, and I will show you that at this point over here, we have a zero slope. At this point over here, let's just pretend that the slope is -1 and 1. If I just go a little bit further, up right here, and here I'll make the slope to be -2. Okay, so I have a slope of m is equal to 0, m is equal to -1, and m is equal to -2. What do you notice? You notice that the slope decreases. Slope decreases. If I continue with this and now have a look over here, the slope on at this point here would be, let's say, -1, and at this point over here it will be now 0. So here's m equals 0 and m is equal to -1. So to make that point clear, if we go in this area here between here and the point of inflection, our slope decreases, whereas if we look at the point between the inflection and the minima, you'll notice here that the slope in here increases. Slope increases. So let's have a look at the sign diagram of the derivative. The derivative sign diagram would look like this. If I called this a B and I called the bottom here a C, the derivative of this, the sign diagram, would look like this: negative, positive, and negative. Now, if I was to draw, for instance, the function, the derivative of the derivative, then my sign diagram at this point A would be negative, positive. So we need to look at the double dash derivative. At double dash derivative, if that is equal to 0, there is a point of inflection that is non-stationary. I can repeat this whole procedure once again for a shape which looks like this, and say, which is a mirror image here of minimum and a maximum, and I can show you that there is a point of inflection at this point as well, which we will call a non-stationary point of inflection. Now this point is non-stationary because I can't draw a little person on a horizontal line. The tangent in here, you'll notice, goes through one side of the curvature to the other side. We can find this particular point only when we examine the double derivative, and it needs to be at 0. I hope that this explains the difference between a stationary inflection, in which we have a horizontal gradient, and a non-stationary inflection, in which we do not have a horizontal gradient.